Slides on your laptop.
I did,
Yes. Okay, well, I should probably get them on.
but I'm not quite as well prepared as usual. I don't have like a amount of memory sticks and order or anything yet.
I'm not as prepared as usual. Either, how much time do we have before we start? Will we 5 minutes late?
We have 3 minutes till before we start. I think. Is that true? No, it's not nearly that bad. We have a lot of time. Let me double check the schedule. Again,
Please, John. Okay, cool.
No. Actually, no, it's 7 minutes. I am confused. We are actually late. But,
Yeah, I thought it was giving me like a plan, but I didn't think it, oh no. I missed
I guess I could start Bluetooth around.
Pardon?
I guess I could, oh, did it? Bluetooth. 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 I could start Bluetooth around, is what I'm
We
doing.
can start the blue sheets around, John can come up. I just need to get the kids.
How you doing, Lydia?
No, this was.
Okay. It was just sitting around the desk, so I didn't know. Put it back on the desk. He's real huge, very much.
Makes sense. Well, it's a restricted, I think they have some. They can't do much. And opportunity, some, so.
Break it, break.
Okay, let's see what this stuff. I'm also pretty, coming from association,
Yes,
this would be,
he's online currently, and he's, unrepresented mother.
okay.
Set up a
And
check.
how do you connect, how does his name get to us?
I'm not from there.
Oh, okay. And so, and Fenway is Fenway didn't like women.
No, oh, that's all right. He asked me to present his slides for him, but,
Oh, okay. Okay, I have, what's the afternoon, I have 2:30, so we want to make it late.
it's true, we have some fun.
Yes, some time. Okay. Let's see if I can work. Are you striving down it, or do you need to find
Sure.
something? Okay, but if you use the
Oh.
ether pad, I can try,
I don't usually do that. I usually do that.
okay. And this should work. How does it look? Good?
Yeah.
Are you be wider?
Yeah, you're not full screen, but
Pardon?
you're not full screen. But- So you could make it a lot better if you go full screen.
It should go full screen. Two, three, six. Oh, that's great. Nope. The phone, that's things, that's nine, that's Trill's. Postal Road right there. Hello.
Okay. There you go.
So, shall I,
Sure. If you want one.
I'm going to start, John, if you want to, there's a clip of something. There's a, here it is. Can you start with picked up the wrong thing.
Yeah.
Let me see. Yes.
Greetings, everyone. This is the beginning of the Trill Working Group meeting. We thank you very much for coming. Please note the note well, and if there's a blue sheet going around, please make sure you sign it. My illustrious co-chair, Sue, has something to say, so go ahead, Sue.
So, one other thing, this is going to be more of a discussion and friendly talk. So it's always more interesting if you're up toward the front and we all can talk. I realize you might feel comfortable in the back, but we always like it if you come to the front. If you don't, there's no forcing you, but I certainly would love to have many of you closer. Okay, with that, we'll start. And besides, if you're using your laptop, the tables are much more effective. Okay, this is our note well. How many people have never seen a note well? Good, this note well looks like all the rest of them. Please read it. It talks about submissions and IPRs and what your contribution is. You should read and understand your friendly note well, because it's part of IETF, and if you're working for a company, it's part of your company to have IPR. Okay, so we are fortunate in that we're getting a lot of documents toward the end of cycle. I've sent working group last calls for several. We've had some good comments on them. We've refined it. But it's always tough to look at the document one more time, but I'm going to ask several people to just please read these documents. We're making the end of the active is passed through. We're making the end of some of the directory assistance type drafts, and we're going on to the multi-level and multi-topology. Please, I think we've got it. As I said, by George, I think we've got it, but please read. Okay, this is our agenda for today. The agenda is this administrative time bashing. We sort of started late. It's really hard to get past the drinks and the cookies. But I'm going to give you status. I'm going to then go through the Yang model. Mohammed. Is Mohammed here in person, or is that the remote? He's remote. So Mohammed's remote, and Donald's here. Ram Kumar, and if I've mispronounced that, Ram Kumar, please let me know. I think that's the way. If you go by R, just tell me that. Feng Wei would love to join us, but it's in the middle of the night in China, and it's tough. So that's our topics today. We'll have 5-minute wrap up. Okay. So we've gotten 2 drafts in the RC editor queue. We've got 2 in the publication request, and we've got 2 drafts that got returned. At this point, the ARP optimization has gone through 1 revision. Thank you very much, Yizao. And We are back to just one more check on it, and then it will go back to Aaliyah's it'll go through working group last call, and then Aaliyah's review again. Please, when we start these review processes, I appreciate your active looking. There are two past working group last call with Trill over IP and Trill resilient trees. I've sent in some comments to the authors. We need to quickly revise these after IETF, so I will actually ping on several of the authors like Margaret over here and try to get some of these things. And I just really appreciate your help, because getting these through, as you will know, Margaret, from being chair and other things, getting it through the last hump is fun. Getting it through the last process is difficult. We have a draft and working group last call, and I've let it sit through this time period. We haven't had many comments on it, but I think there's been some interest, so please comment. We have drafts that have revision, and I think the smart end nodes and address flush. The address flush will go back through working group last call because it didn't finish. The smart end nodes, I think you know what needs to happen there, and we will again go through working group last call. Now, what does all this mean? What we're doing is we've done tremendous good work, and we're pressing it all toward RFC. So help your fellow authors by pressing it toward RFC. Now, there are a whole bunch of drafts that we've sort of adopted, and I'm going to go through them and sort of classify them. Why am I doing this? I see that we've sort of come to the end of what I think are operational issues. We've gone through the active, we've gone through the directory assistance, multi-level, multi-nickname. Thank you. Is it here? Oh, there it is. I got it. Nope, that didn't work well. Let me go back. Okay, one more. So, for example, we have the Trill data center interface, and we have the Trill, we have some Trill transport over MPLS. I will try, I think most of those drafts are fairly well cooked. I will ask you to please review. The Yang documents we'll cover next. What you're hearing me say is I think we're sort of to the end of several large pieces of work, with the only thing hanging out is security, that we've got some individual drafts, and the any urgent thing we hear from you. We're at a place where most working groups go into a hiatus or sort of go into a death rebirth thing. This isn't because technology isn't working, it's because in reality, you've done a really, really good job. We've gotten through a whole bunch of stuff. I think we've gotten to all the product lines, what they need. For those who are shipping Trill product, it would be, or Trill sort of product, tell us if we've gotten everything. But we've tried to focus on what we've got. If there's something we needed, we're heading toward that. Gee, we've gotten through the first piece. We've defined everything. We'll let it set. If there's some urgent problem, I'm sure the ADs will pick up and move it out. But we're at that, coming to one end. Why is that important? I really want to get all the RFCs through the process. Okay, I probably said it 10 times now. Hope read the drafts. Okay. And these are the documents we have done. You see this status. And these are our milestones. And looking at these milestones, we're going to readapt. The milestones are out of date, but we will, we've completed a whole bunch. This is a tremendous working group. Its technical capabilities have been a joy to work with. But we have a few overdue, mostly because we've recycled a couple of these in review. I'd like to catch up our interviews, and we were going to recharter or shut down the working group. I'm not sure we're going to make July. We may be November, but I think we're heading toward that hiatus. That's your chair trying to. So if you got some challenge on that, that's where I think we're heading. Again, because I think we've finished. Let me give you an example of another working group that went through this. BGP went through a whole long cycle where we had a whole lot of work, and then we went into hiatus for a while. We sort of saved that because we really didn't have something interesting to say. But then when we came back, we had a lot of interesting things to say. And we're still finding things that are changing in the BGP environment. It's just for a while, we weren't changing. So take this to be like Trill, like BGP. Okay. John, I think I need to pick up the next one. Okay. How many people here have worked with Yang? I think he's out. Okay, good. Now, this is a little bit of talk about a challenge. When we had our Yang models, Trill Yang, which is the basic configuration, the PM and the OEM, the PM which actually works off the OEM, we did a lot of work ahead of everyone else. And then TISA thought it would be a really good idea to have Lime and to make the Trill model go under Lime. Lime is finishing its work, and I don't know that it got to everything we thought it would. So I'm faced with three options. And for those who are working with Yang and Trill, option one is to working group last call and send through the process the modules, because it's my understanding from Deepak and maybe other people who have implementations that you have implementations of the existing Trill Yang models. They will not be exactly up to latest snuff for some of the requirements in format. So some stuff is easy for format to change and some stuff is fairly hard. My first option is we're not going to really address the hard changes. We're going to say these are adopted and used. In that case, I will collect from Deepak and any one of you that have Trill configuration Yang models, the information and send it to the ISG. The second option is to change the Trill PM and OEM to be dependent on Line. That means you have the Line base and then you have to do new models for that. Deepak's original comment to me in email was, no, I'd rather stay with the original Yang model. Okay. We can do both, but that takes a bit more energy. I'm willing to do that, but I'd like to start now because Yang models have taken us a while. Any feedback? Isao?
Okay, I would like to see we take option one first.
You want option one?
Yeah.
Okay. That would be, and your implementation wants option one.
That's better to, it can,
Yep.
use our implementation, so.
Yes. I'm sorry, have to ask that as chair, even though I know the answer. Yes. Okay. So I have Cisco and Huawei wanting that, and I will probably go with option one. That was your answer, is 2 implementations. We're going forward. By the way, my definition of interoperability is 2 implementations in the field. That is prejudiced by my work in BGP. If anyone wants both, you must tell me within this week because we'll go on. And I will tell the Lime chair, that's nice. If you get someone to volunteer, go forth. But we're going to stay focused on the first option. Okay. And if you feel shy about the mic, come and talk to me afterwards. But I will make a fairly call. Let me just give you a little information about some of the challenges now that I've gone through the major question, which is one of the challenges that is that in the future, in the sort of Line time frame, we would have to work with the revised data store. And revised data store has changed the op state to be separate than the rest. It also has taken dynamic data stores such as Trill R2S might be into that. Okay, and I've gone through some of that already with Line. I think I've gone through that. Let me see if I can get to the next slide set. He gets remote next. It's Mohammed, so he's remote. And I've never done a remote, oh, wise people. Okay, so I'll just bring up the slides for us.
And so how do we pump his voice?
Okay. Let me pull up the
Speak.
slides. Excuse me.
Hello. Hey, look at that. Yeah.
Okay, I do have the right one up. Just a minute. Thank you. Go ahead.
Hello
Mohammed.
everyone.
Thank
Hello.
you for joining us remotely.
Yes.
Okay.
We can hear you.
Okay. Thank you. So in this document, what we are going to discuss here is bringing up FGL into the Trill header. So how we are going to do is we are going to subsequent slides. So this presentation covers three problems: uh, making FGL continuous against discontinuous, as in the present RS. Eliminating 32 bits of Ethertype space in FGL for 4 keystroke purpose, bringing FGL into Trill header as against inner header. So what exactly it was like, FGL was in the inner header, that is in the original data where it is. So what we are thought of, bring FGL into the Trill header. And this document proposes changes in the FGL packet structure that is described in the subsequent section of this document. Can we go to next slide? Okay, this is how the present frame structure is. So we can see after inner MAC source address, we have ether type, that is 893B, and we have two ports, that is inner label and high part and inner label low part. Sometimes it is a little bit confusing that why it has been discontinuous. So that's where we are thinking of bringing that FGL into Trill header. So can we, and again another problem here is the ether type. We have again 4 bytes of ether type. So that is again the waste of means 4 bytes. Can I go for next slide? Yeah, that is what I discussed in the previous slide, that FGL is divided into two parts, uh, 12-bit higher order and 12-bit low order part, which sometimes is confusing. And it is also FGL added or removed in the original frame space, which causes overhead in the processing on the edge arbitrages. So what we are doing now here is that we are adding FGL and removing FGL in the original frames space, that is little bit overhead on the edge arbitrages. Next slide. Okay, so what we are doing here is we are proposing a new frame structure where FGL header will come inside the Trill header. So you can see the original header will be remain intact. If someone wants to, we don't want to change anything, means original packet will remain intact, whereas FGL header will take care of the FGL label. Yeah, can you go next slide? Yeah, this is how it looks like. So Trill header is whatever we are using as of now. So FGL header that is having that is in the down. So you can see here we have some information regarding FGL header, I bit, R bit, P field, priority field, and we are bringing entropy label also. And the entropy label is because uh, what we now have is that we have to go all to the deep packet inspection to find out uh, for doing a load balancing on core side. Means if in core or bridges, if we have ECMP parts, then we have to do a deep packet inspection for load balancing. To avoid that, what we are thinking is to bring entropy, a new entity called entropy label in the FGL header. Next slide. So this is how it looks like when we combine the headers, Trill header and FGL header. You can see here that FGL header will come after ingress nickname. So we can go to next slide where I will discuss each and every field. Next slide, please. This is the Trill header part is same as described in RFC 7780 with few changes in its version field. We are going to change it with a new version, means bringing up a new value. Right now it is 0, so it might be 1. So that indicates that the Trill header has an FGL header. So FGL header is described as below. So I bit is 1 bit field. When set indicates valid FGL is present. So R bit is 1 bit field, which is a reserved field. Next slide. Okay. P field is a 2 bit field whose value provides information on the next field, that is priority field. So the priority field, in priority field value 0 of P field indicates that priority field is copied from the inner VLAN header, which is a 4 bit field including DCI, means DCE, that eligibility, drop eligibility indicator. So 4 most significant bit will be used for priority. 4 least significant bits should be set to 0 and ignored while doing packet forwarding decision. So can we go for next slide? Okay. Value 1 of P field indicates that priority field is copied from inner MPLS headers EXP bits, which is a 3-bit field. Hence 3 most significant bit will be used for priority. 5 least significant bits should be set to 0 and ignored while doing packet forwarding decision. Value 2 of P field indicates that priority field is copied from inner IP for headers TOS or DSCP field, and hence all 8 bits will be used while taking forwarding decision. And value 3 of P bit field indicates that priority field is copied from inner IPv6 headers traffic class, and hence all 8 bit will be used while taking forwarding decision. So these all are things we are trying to use for doing the QoS, because whatever we have, this will give an administrator or user a free hand on what basis he want to do means QoS Trill or bridges. Yeah, next. Okay, this entropy label is a 16-bit field which is calculated based on hash generated by inner packets layer 2 address, means MAC addresses, source or destination MAC address, or layer 3 addresses, IPv4 source or destination addresses, or IPv6 source or destination addresses, or L4 addresses, means TCP or UDP port numbers, or combination of all the above. This is used to do load balancing distribution or load distribution of data on ECMP of core or bridges without doing deep packet inspection. Now what we have to do here is we have to do a deep packet inspection, go all the way inner to the inner packet where we will try to do in ECMP. Otherwise, we will choose L2 field or L3 fields to do ECMP, but we have to go to inner packet and we have to do a deep inspection. So by bringing entropy level, what we are trying to do is, again, we are giving a free hand to uh, means administrator or someone who want, like whether he want to use inner L2 headers or inner L3 headers, and don't do a deep packet inspection. And without that doing, entropy level will help us to do a load balancing. Yeah, next slide. Okay, so now FGL will come here after this entropy label. This fine grain label is a 24-bit label, which is same as whatever it was earlier. So what we have made is this as a contiguous. Earlier it was discontiguous. So this indicates the frame belongs to which particular broadcast segments. So, and on top of that, we have reserved fields for future purpose. I think we can go for next slide. So what exactly it will provide us, what are the uses that we are getting from here is that with entropy label, load distribution can be easily done on ECMP in core arbitrages, and achieving of QoS in Trill can be done based on customers' requirement. On top of that, what we can do here is that there are some models in MPLS for achieving QoS, like pipe model, short pipe model. All those things we can bring into the Trill also, whether if really some customer wants it to be like that. But for achieving QoS in Trill, what I can see here is that right now we don't have that much of free hand provided to the administrator. If he wants to stay whatever is there in the Trill header is indicating to him, or if you want to change, so we can give him a free hand if you want to take the decision based on the inner headers, which inner header, where is L2 header or L3 header. If L3 header means, again, how he want to do it. So by bringing this priority field into FGL header, I think we are giving a free hand to uh, a customer or to the administrator how he want to take a decision. And another thing that is most important is that achieving of different mode of services easily, like VLAN based service instance, VLAN bundle service instance, VLAN hour bundle service instance, etc. So it will become very easy when we bring FGL outside the inner header. So we can go for next slide. Next slide. Okay, so this is what I have. So any comments on the proposed idea is always welcome.
So while Donald's going to the mic, let me ask um, an operational question. This proposal hints that you've got customers who are needing these changes. Can you provide some more detail on why the original stuff, original fine-grained label wasn't able to accomplish some of these pieces, and what your customer scenario, don't give enough so we can tell the customer, but if you would just give us a little background on what customers you're working with, why it's important to them, that would really help me in my evaluation.
So right now we don't have any customers as of now. So what we can see in the different means technologies, right, what we have right now is they are always means want to have something like FGL to be outside the inner packet headers. So what we are doing here, we are putting FGL inside a inner packet header. So they always have means want it to be outside of it. On top of that, as I told, that entropy label, what we are proposing will have, it will give a very good chance for load distribution. Means whereas don't do any deep packet inspection, that will bring a lot of overhead to the 4R bridges. So it has to go all the way, inspect inner L2 fields, inner L3 fields. So, and also achieving of QoS in Trill, what we right now we are doing is we are using sometimes VLAN header, outer VLAN header. If the technology is like PPP, we don't have VLAN headers also, right? So, and also the means lot of models that we have in QoS, like pipe model, universal model, and short pipe model, that is in MPLS diffser. So to bring all these things, I think somewhere we need to make this FGL, means to bring this FGL outside the inner header and to put in the Trill header. Ideal, it will become easy also, because sometimes it is confusing when we see the ether type values 2 times it has been repeated. So so we are wasting around some uh, uh, 2 plus 2 means 4 bytes, where to tell that this is the ether type. Uh, so that's where I think we need, I think that this will improve some of the things which right now FGL is not having. So frankly speaking, there are no customers as of now, but this is as a means proposed, means idea by me and Donald. So
Okay, let me summarize because some of the meat echoes coming in, but it's trimming parts of your words. So I'm gonna just summarize what I think I heard, and please correct me. And I'm sorry for the quality seems to just clip certain things. So my understanding from what you just said is you have some, what I guess would be data center customers that need a lot of ECMP. You have other customers outside the data center that are attached to VPNs who need some of the split out that the fine grain labeling has. And then I'm not sure about the third case, whether you have some other QS requirements based on a particular application voice or something else. Again, I apologize, but I'm just trying to characterize, the needs, because data centers are news needs, combining them with exterior, some QoS is new needs. If you would just work through that, and Donald, if you heard it better on the types of users, you're welcome to comment, or John, if you heard any more on the users that I missed.
before that, yeah.
Please answer, go ahead and answer, Amar. Did I understand your types of users correctly? And your need?
Actually, so there is no customer as of now. So means anyone who want this
Okay.
proposal. So this proposal is like after seeing lot of other technologies. So who has a FGL kind of header which is outside the means original header. So that's where we are
Okay.
trying to bring it, but we don't have any customers as of now. So if we bring it,
Okay. But
yeah.
do you perceive a particular customer market? Thank you for confirming that, Umar. Do you perceive a particular market that this will help you reach? I'm trying to get a sense of the push to change a header. Can you talk about that just for my background?
I think definitely someone will come back to us. Means what I heard is a lot of customers are like because of FGL that is inside the uh, original header, the customers is are really not understanding what exactly why exactly it should be inside it.
Okay, thank you. Just a minute. Donald or John, if you, I'm asking about use cases.
Well, I mean, along that line, I'm just kind of curious, if you don't know who the specific customers are, what the scope of their problem is, how tightly bound is what you're looking for? I mean, do you already have alternatives lined up if you cannot get this achieved?
Excuse me, I think
Basically, I'm curious is what is your plan B? If you can't get this to work how you want it to, what is your alternative path?
I don't have any plan B as of now. Means, continue as if how it is going on. So, for example, how we are using FGL as of now, continue with it. If no one is ready to accept it, and it is better if we have some kind of new draft in the draft shape, and someone is then ready to try it out.
So,
All right.
Thank you very much, Umar. Now on to the rest of the questions.
well, this is Donald Eastlake with Huawei. I just wanted to make a couple comments and things. I believe one of the things is that the existing FGL standard, I have some slides to go after this, mentioned that the existing FGL standard hasn't actually been implemented in merchant silicon. It's kind of a problem. And this proposal, by making the FGL field contiguous, should make it easier for network processors to handle it. And a number of other aspects of it are designed to make the fast path implementation easier so that it can be done better with network processors, or would be easier to implement in merchant silicon in the future. And that's another this little point. These slides here, I was thinking they propose changing the version number, which is kind of a big deal in the Trill header. There's other ways of doing it, which would be there's some flag fields in the Trill header which are critical flags. So if they're set, they would cause any switch that didn't understand it to reject it, which don't require changing the version at all. For example, one bit in that area is the bit which currently indicates that the optional flags word is present. So you could just use another bit in that area to indicate that the FGL header information was present. So I think that might be a little easier than trying to change the version number.
The only point I would add really quick is that, well, yes, there's been no merchant silicon implementations of it. There were custom ASIC implementations of it.
Margaret Cohen from Painless Security. The first question I have, I guess, is we'll go over the drafts for this meeting, but I didn't find this one. So what is the draft that this is documented in? Oh, but these changes, is there a draft for this? Okay, so I will not feel guilty that I'm asking questions based only on looking at the slides. Page 8, I think it was, slide 8. I have a question about this. It sounded like we're going to have a new header version that says that the header that follows is an FGL header. And then we're going to have a bit in the FGL header that says it's a valid FGL header. Now, what is it if that bit isn't set? An invalid FGL header? I mean, I don't understand is that space always going to be reserved? But if that bit's 1, we should do something with it. And if not, it should be all zeros. I don't understand what this means.
That I've seen, that I'm not quite as upset with, because I've actually seen that in other routing drafts as they try to migrate versions of headers.
So is that what it means? This space
Yeah,
will always be
essentially.
reserved, it will be all zero? Is that what you're proposing? I'm not sure if your name is Mohammed or Umair, and so I'm not sure what to call you, I'm sorry. Could you let me know?
Yeah, you can call me Umair also or Muhammad also.
I can
Yeah,
call you what?
you can call both. Means,
Umair? Okay,
yeah, yeah.
both,
Right.
okay.
So now about the I bit. So for example, might be we'll use FGL for some of the reservation purpose, or sometimes the FGL values might be all zeros. So then we can tell that there is a invalid FGL value which is there in this header, and you can directly drop it. Uh, so that is the purpose why we are bringing the I bit. So if this is not the way to means like to handle it, I think we still have time and we can think about it. But right now the main intention is if something which is all the value is zero, then it will indicate the R bridges to directly drop that frame.
Okay. And then I had a question about, a few slides from now, there was if the value is 1, if the value is 2, if the value is 3. There we go. One thing I think you should at least consider here is that deciding what to do by looking at a value and then a field is computationally more expensive, right, than just deciding what to do based on a field. And I wonder if it's possible, and I'd have to look and think to know, to have a way that we encode one field that could be as much as 10 bits long, because your 1, 2, and 3 are going to take 2 bits plus your 8-bit field, right? If we have a way to encode one field that we could map all these values to, so that there's a consistent set of fields instead of having 3 different types, is something I would wonder about in terms of if there's a meaningful way to do it. I mean, if they're completely disparate information that they're trying, then we are sort of mapping to it by having 1, 2, 3 at the front, right? But is there a way that we could actually map these to be meaningful in some simple way? Like, for instance, are the 3 bits really indicating something that could be mapped into the 8 bits? I don't know. I know that the 3-bit toss field has previously, for various things, been mapped into other types of traffic class fields, like the diffserv field. And I wonder if we could get to one set of information we have in the Trill header with mapped values from the other fields. I don't know.
Okay.
And then my only other comment is on the, why don't you answer that question? I'll give my other comment when you're done. So go ahead.
And the reason behind why these are 2 fields, because one, it indicates that from where we have copied this priority field. Then when we want to copy it back, means when it is going out of Trill campus. So if some customer want in such a way that if you want to copy the priority bits back to its original header, so it will help him to know where he has to copy it back. So whether it is L2 header, whether it is L3 header, so where exactly he want to copy it back. That's why we have divided
So
into
you
2.
think it might be modified, these fields might be modified in transit?
Yes, correct. Yes, that's why it means we have means different type of models in QoS. As what I was discussing, like we have pipe model, we have
Right.
a universal model, we have short pipe model. These models means each model is different from other. In a case where sometimes we don't want to copy it back, sometimes we want to copy it back to the original header. So the reason is just to the edge or bridge, it will indicate that where you want to copy it back, means whether to the L2 header or L3 header. The first 2 bits which is in the P field will tell to the R bridges, edge R bridges, where you want to copy it back.
Yeah, I'm pretty sure it isn't safe to modify all of these in paths. So, but yeah, Donald wants to say something about this.
I don't want to, Margaret has another comment, but I just wanted to say that that there seems to be enough space in this FGL header that you can preserve these things and, copy them into there. But at some level, the current Trill architecture assumes that there's always a 4-bit handling priority for the Trill data packet. And basically the drop eligibility and the 3 bits of priority, and the Trill switch ports are bridge ports, and they sort of have these 8 queues. Now, having additional information around is fine, but it's sort of would be good if there was a 3-bit priority and a 1-bit drop eligibility field available. And having additional information, which is okay, but like I said, the Trill architecture sort of assumes there's that 4-bit summary of the priority for handling things.
And then the third thing I wanted to ask about, let me try to remember what it was. Can you just go forward a little bit on the slides? Because maybe it'll come back up. Oh, go back one. One of the things that you can get into with attempts to calculate entropy is if you have one way to do it and a good hash algorithm, you will get an even distribution, okay? But if you have multiple ways to do it, you get a less even distribution, right? Because you are hashing on different stuff. I think you want to look into, and I'd need to see actual text. This isn't like enough information for me to make that judgment, but when you do that, you want to make sure that you talk to some people, security people or something, to make sure that whatever you're coming up with we might use this or we might use that, actually is going to result in an even hash distribution. Because that isn't always the case if you can use these fields or those fields or some other fields. And then the hash algorithm also has to be well defined in order to come up with an even distribution. So that was my only other comment. That was just random advice worth what you paid for it.
Thank you, Margaret. Is there any other questions or comments for Umar? Okay. We will take this draft to the list and have further discussions. It's the first draft. Umar, you would do me a favor if you would think a little bit about the use case you might deploy in this and send me a note on that. Thank you.
The only thing I would add really quick, just hopefully as a way of encouraging people to read into this, assuming that this all gets written up, is that there were a lot of things we wanted to do when thinking about FGL that we didn't do because there was so much resistance to any sort of header change of any sort. And the fear was that it would cause all these ripple effects in the market. As Donald pointed out, there are no silicon chips supporting it. The custom chips that were designed to do so, I believe, are no longer shipping. And so the resistance to doing that isn't really what it was before. And so if there really is a good reason, my point is that this might be worth looking into because the situation has changed.
Right. And I should ask the final question, Umar. Are you intending this for software implementation? Because at this time the speeds can do it. Or are you intending it for some of the Trill labels, fine grain labels to be put in hardware? Do you know at this point?
Excuse me, can you?
Will it be a hardware implementation that does hardware forwarding, or will it be a software implementation that does forwarding by the Trill fine grain label?
It is a hardware forwarding agreement.
So just let me repeat that. Hardware is your intent.
Yeah.
Okay, thank you. That's also very good information. Thank you for putting up with the remote speaker. It'd be good to give us feedback to the chairs how that worked.
Thank you.
Yeah, thank you very much.
And thank you for getting up very early in the morning. If I've got it right, you're at 5:30 in the morning, or is it 6 o'clock?
It is 2:52 a.m. in India. Right now.
It's what? Where are you?
I'm in India.
2:53 a.m. Yeah.
Yeah. I'm
Wow.
in India.
You look very fresh and alert, so we
You
appreciate
do.
that.
You did wonderfully for 2:53 a.m. and 2:30. Wow, that's dedication.
Thank you.
Thank you so much. Donald, I believe you have another thing that goes on the same topic.
Yeah, so originally I was going to propose a somewhat different way of doing this fine grain label thing, but I turned out when I looked at it, it didn't work. So I didn't like that. I just want to give a few slides on the sort of little background and backwards compatibility stuff. Next slide. Sure. I have control. Okay, so, you know, the purpose of fine grained labeling is to provide a 24-bit label like a tenant ID when you need more than the 4,000 VLANs because you have one that number of classes of traffic to separate. And the
It's me. It's me.
okay, I don't know.
It's all your cybernetic
The V-
implant.
It's-
Anyway, basically the VLAN on the native traffic, if you configured it this way, gets mapped into an FGL at the ingress R bridge, and then the egress it gets mapped back. And I guess the mappings can be different, and it also provides a way where you can have the priority set for the traffic, which is different from that externally and can be restored. Oh, did I push some stuff here? Yeah, I pushed it. Okay. Yeah, the priority at the FGL level. Okay, so this is what it looks like. This is very similar to the previous diagram. And you might wonder like how this strange double ether type thing came out. It sort of comes from the Ethernet, from the tag stacking stuff. I mean, if you go back far enough, a certain large commercial vendor started putting 2 customer VLAN tags in a row to indicate essentially a 24-bit label. And of course, that was never approved as a standard by any standards body. And in fact, what IEEE did is they later said you need to use a service VLAN followed by a customer VLAN if you want to effectively get that, because they thought putting 2 copies of the same tag in the row was evil. Or anyway, it certainly was never standardized and never approved. So it certainly wasn't kosher. So anyway, so we sort of wanted to do something like that, but I don't remember if there was a liaison or anything, but basically we were basically told anything we wanted to do with the customer or service VLAN tags from IEEE had to exactly follow IEEE rules. We couldn't do anything different. So we said, well, we'll get our own ether type and then we can say what the rules are. So we got our own ether type and we essentially did what is commonly called tag stacking, but with our own ether type. So that's how it ended up that way. So one of the things is, let's assume there's a draft and standardization of the proposal that Umair has presented. There will be a problem. You might have a link with different ports on it from different R bridges that use different FGL encodings, and that's not going to work very well. So just one of the details that we would need to clean up to do this is to have a bit in the capabilities of the either in the port capabilities or the switch capabilities indicating which variation they were using. And if they're all the same on the link, everything's wonderful. It might be better to be per port if there could ever be something that could convert from one to the other, or you could have it per switch if you wanted it to be simpler. And if you ever do get which is on the same link, then you really can't send FGL traffic because the other end won't understand it. If the FGL is, you could have a port that understood both the existing format and it could also and the new one. But if you have 2 ones that are fundamentally incompatible, probably the safest thing to do is just not establish an adjacency on that link. And this should be a very rare situation. Would only be in case where the network is perhaps not that well managed. In a well-managed network, a lot of these incompatibility problems should be very rare. Nevertheless, for safety, and make sure you don't send something to the wrong tenant or the wrong VLAN and violate security requirements, you do need to indicate the format you're using and you need to check for this incompatibility. So that's really all I wanted to add. So,
Any questions? Okay, we'll go on to the next set of slides. Donald, what was your intent? Was to just work this out with the previous one?
So yeah, I mean, Umair has checked with me before, and both our names on the previous draft, so previous slides. So the next step would be to produce a draft. So I think it should. Obviously, a first draft doesn't have to cover everything, but it would be good for it to at least mention all the issues and have a sketch of a solution to any of them.
Thank you, Donald. We're going to go on to the next thing on our agenda, which is the parent selection. Is Ramakumar? Good, you're here. Wonderful, in person. Let me see if I can get these slides up. Please take once I get your slides, it'll be just easily. And thank you for redoing the slides for us. Okay, give me a moment to get to the right screen. Does this look good? Did I get the right one?
Yeah.
Okay. Here we go ahead and just tell me when you want to change the slides.
Okay. So I'd like to make the case for this particular draft, which solves a known problem in Trill. My name is Ram Kumar, and I work for Bouquet Communications. So what is the problem that this draft is trying to solve? It's basically that the default parent selection rules standardized in the Trill tree construction process can lead to situations where parents for a particular node in the tree shift unnecessarily. Okay? And I'm aware of this creating problems for customers in the field. And the draft here basically tries to provide actually two different solutions which can be used for this. And I'll explain what they are and which one is preferred as I go along. So the crux of it comes down to this, basically the lower paragraph on the page. Okay, so and I'll skip one slide more. So it comes down to this. So basically, if you're building tree number J, and you have a situation where a node can be pulled by P different parents, then the way Trill chooses the parent for that particular tree is it orders all the parents in ascending order of 7-octet ISIS ID, and then sets them up so that the first one has an index of 0, the last one has an index of n or p-1 or whatever it is. And then the parent choice is then made as j-1 mod p, where j is the tree number and p is the number of parents. So what problem does this cause? So let's take the example of this spine leaf network that's shown on the right side here. Basically, let's say that we are talking about tree number 2, and that A is the root node for that tree. So you start off the SPF at A, and then it tries to go ahead. It tries to pull the nodes that are optimally reachable from it. So on the very first shot, it's going to pull in 1, 2, and 3 because those are the nearest nodes that are attached to A. So, and for 1, 2, and 3, there is no choice of parent because the tree root is A and only A can be the parent. Now, as a second step, now you'll start looking at other nodes which are reachable through 1, 2, and 3. And now you'll find that you can now reach B and C. Okay? Now, when you try to pull in B and C into the tree, you have a choice. They can be pulled in through 1, through 2, or through 3. So that's the rule that was on the previous slide is basically acting as a tiebreaker for this particular situation. So in this case, what you will do is so let's say they in ascending order of ISIS ID, the parents are 1, 2, and 3. Okay, so 1 is considered to be at index 0, 2 is considered to be at index 1, and 3 is considered to be at index 2. So because this is tree 2 and you have 3 parents, potential parents, you will compute the preferred index as 2 minus 1 mod 3, which is equal to 1 mod 3, which is equal to 1. So you will go with, so the node at index 1 was basically 2, if you see the list there, right? So 2 will become the parent for B and C. So the tree looks as it does on the left side. So this is fine, but what happens when, let's say, node number 1 went down? So again, you're forced to recalculate the tree at that point. At that point, what happens is A pulls in 2 and 3 directly. Now, again, when you're pulling in B and C, you have a choice. They can be pulled in through 2 or they can be pulled in through 3. So again, order the parents in ascending order. So they are 2 is at index 0, 3 is at index 1. You run through the calculation, which is basically 3 number minus 1 mod number of parents, which is in this case 2 minus 1 mod 2 parents now. So is equal to 1 mod 2, which is 1. However, the node at index 1 is node 3 now. So in the updated list. So now what happens is the parents for B and C shift from 2 to 3. Okay, so this causes a lot of issues in real networks, because basically you have running traffic that can get disrupted. And there was a real customer case where some kind of I think a financial customer or somebody was looking for a way to solve this. So that basically led up to this. Okay, and there are as far as I can tell, there are 2 ways to solve this. I'll talk about both the approaches and why I prefer one of them. So the simplest, easiest way to solve this is using the affinity sub-TLV. It's a sub-TLV of the router capability TLV, which is already used in many other scenarios in Trill. And it's published by in terms of semantics, it's published by the parent, identifying which children it wants to have a parent relationship with, and the specific tree on which this is to be done. Okay, so it's quite powerful and needs to be used with certain caveats. So the way the approach 1 works is that the operator configures parent stickiness on a particular preferred node. So in the previous example, if you go back to this slide, right? So on node number 2, he can configure this parent stickiness, saying that my preferred parent in all tree situations is 2 for that particular level in the tree. So once he configures this, what happens is that the 2 then runs through a tree calculation again. When it runs through the tree calculation, it does not use the default Trill rules. And at the same time, at that point, it has not published any affinity TLV. So it ignores its own any affinity TLV that it might have generated. But because it has now a preferred parent status, it acquires so when you're in the SPF construction, you see that you are in contention to be a parent for those children, and it asserts that parent relationship basically. So it immediately pulls B and C in the previous case through itself, and becomes the parent of B and C. Now, once it has run through one calculation and it has waited for some measure of stability, let's say a certain time interval or something like that, then it goes ahead and publishes an affinity sub-TLV saying that, hey, I'm the preferred parent for children B and C on tree number 2. So once this goes out in the network, everybody knows that 2 wants to assert that parent relationship, and they all bind to 2 as the parent. Okay, so subsequently what happens is, so if you take the same situation in the previous, with this approach 1 scheme implemented, what happens is that when 1 goes down, you, even before 1 went down, presumably when 2 was configured with the parent stickiness, it went ahead and published an affinity sub-TLV, which went to every node in the network. So even when 1 went down, nobody is using the default Trill calculation anymore. They already know that 2 wants to be the parent. It has sent its affinity TLV, and which is valid right now. So everybody will pick 2 as the preferred parent. So the parent will not shift to 3 when 1 goes down, basically, which is what you wanted to achieve. So there is a second way in which you can do this. This approach is a little bit harder to implement. So the way it's proposed is that, so the draft presents a modified form of the Dijkstra algorithm, where basically if multiple parents can pull in a particular child at the same optimal cost, then you can insert a policy filter in the tree construction saying which will drive your parent selection basically. The policy filter is abstract. You can put whatever, you can code it however you want. But what the draft talks about is that you make it match your previous stable tree construction. Okay, so to begin with, let's say you started off with Trill, the default Trill rules, and your tree looked like it did on the left side of the slide here. So once you know that 2 was the parent, in subsequent tree calculations, you'll continue to maintain 2 as the parent, because your policy is always referencing the previous stable tree construction. So, by doing this, you basically preserve whoever was the parent when the first Trill parent selection was applied. So this will also solve the problem, but basically here the difficulty with this approach is that you're kind of doing a kind of time synchronization in a distributed network, basically. So this is harder to do, and with some caveats it might work, but it's probably going to be best suited for like small to mid-sized networks. But and this slide indicates how that works. So when 1 went down, because 2 was the preferred parent, you continue to latch to 2 in your subsequent recalculations, and your policy guides that. But still, between the two approaches, approach 1 is substantially better preferred. Okay? And because it's guaranteed to work, everything that you need to implement approach A is already there in Trill, and no change to the protocol is needed. But I still put approach B there as a backup, just in case something prevents approach A from being used. No, and there's no IPR on either of these approaches at Bouquet. So basically, I'm requesting that this be adopted as a working group document because it solves a reasonably important problem in Trill. However, in the published version, there are a few mistakes and logical inconsistencies that I need to fix. I have a private draft which I will probably upload after the current IETF. One of the questions I had was, should we carry approach B all the way till the end, or just remove it and leave it at approach A? The other thing is the policy-driven mechanism listed in approach B can be used in some other situations, particularly if you want there can be alternative default parent selection rules. Okay, so you can probably come up with other formulas which will try to do a better job of distributing the links between the parents, the children between the parents, basically. So if there's any approach interest in pursuing that, maybe we could probably use approach B as a separate draft. And approach A can be enhanced to add node redundancy for that for the preferred parent, basically. So one other question I had was the draft is currently experimental, and should it be changed to informational? So that's about it. Any questions?
So just because I may be behind in the draft and the draft changes, the affinity TLV that you're proposing, is that a new version of Affinity TLV that I missed, or is that the original Affinity TLV that we've had?
It's the same one that you had. No change.
Okay, so the change is really, is this an application, or since we're not changing bytes, or is it just a mechanism for changing parent selection? In other words, we're using the same affinity TLV for type A. We're changing the paragraphs in RC 7780. Is that what I understand correctly?
No, it's just applying the same existing affinity TLV with the same semantics in a new situation, basically. It's not really changing.
It's not really changing anything.
It's not really changing.
Okay. Okay, so it sounds like an informational.
Okay.
I'm sorry if if you're not changing anything, it's an informational good idea on how to prevent your customers from flapping. But if you're not changing anything in any of the drafts, sounds like if you've got customers that have problems, this is a real important thing to look at. And I would state those things to the list and indicate the problem, underline the problems you're having with customers so that we can consider that in the process of adoption. It sounds like are you having lots of customers, a few customers, and this is an edge point? Can you give me sort of
So I should clarify one thing. I mean, there was basically a presentation in my previous job where they pointed out to a customer who was looking for it. So I'm aware that people are looking for it, but in my current job, I'm not aware of anybody needing this.
So this is from a previous set of customers. Okay. Other questions on the technology, folks? Anyone have looked at it? Well, thank you for the very nice presentation. I think that's an interesting problem with the parent node shifts. I've seen that in other protocols. Thank you. Thank you very much. Okay, we're working down toward the last part of the agenda. I believe we have just one more thing, or am I with the smart end nodes? Um, Feng Wei did some revisions to the smart end nodes based on comments. Donald will present because it's, I guess, very late in China as well. Okay, give me one moment, Donald.
Sure, that looks like a great slide.
You want me to just go to the next slide?
Sure. Yeah, so I guess Fenway is not available, and the changes in this version are mostly due to my comments. So, anyway, these are the advantages. It saves in the learning space, quicker to refresh, supports fine-grained, label-aware end stations, if you should ever want such a thing, which you might, I guess. This draft's been around for quite a while. It's been revised several times. Next slide. Oh, I don't have.
No, I'm sorry. I thought you
I should
were
grab
going
Sorry.
I'm sorry.
So changes from the last version. It ends, let's see, now it only supports pull directory information because how to do push was unclear. There's SADI stuff in there, which was pulled. Basically, these are all results of my comments on the previous version. And exactly what MAC address it uses for where's multicast frames has been changed to the all averages multicast address. Let's see. This is more changes in this version. If you get a native multi-destination frame from a non-smart end node, then you have to send the Trill data package to the campus and also out of port to back to that same link so that the smart end node on the link will pay attention to it. So basically the question is whether these fairly extensive changes actually are put in good enough shape for doing another working group last call, and I think that they do. So we should think about it and start one fairly shortly, I guess. They've been through one working group last fall and modified as a result.
Any comments? Because this is one of the things I wanted to try to get resolved was the smart end nodes draft going to final working group last call. The real comment was on the native multi-destination data.
Yeah, the previous one just didn't really cover all the cases correctly. So there is another draft which is the directory assisted encapsulation, which might be working group last call at the same time. The topics are similar enough that it might be convenient to people to review them both at the same time.
And I think that would be very beneficial because that finishes some portion of our directory assisted work. Well, we've come to the end of the session and thank you for your attention. We will call it into the close. Donald, if you will post any questions to the draft, and then I will post later in the week a working group last call.
Blue sheets?
Blue sheets, please. And Kumar, if you will post comments about your some general idea of customer needs, maybe that will engage people. I don't want you to break any company confidentiality, but if you just describe it. And I think Umar went to sleep. So thank you again.
Thank you very much. Say good night, Grace.
Oh, timing is everything. Okay.
I have to admit that the venom that came out in the early days of Trill about making changes to the pattern surprising.
Right.
It was so frustrating because it seemed like everything we could have done was really cool. Like we really would have actually impacted customers. Like we couldn't get this header from one thing. It's like, dude, people spend on ASIC for 18 months.
You're not ever locked in for that long.
Yeah, and the answer was it really locked in and was it just an effort to kill?
Well, as I said to someone the other day, most opposition to things in IETF can be distilled down to, but that's hard.
We'll take those down to the registration, or if you'd like to, you're welcome. Next is my friend, the GROW working group, one of those.
What is grow?
GROW is, problems with growing the IP, address space, mostly it's BGP, policy issues. Is that my plastic thing?